if you look at software testing, and I've been saying this for a long time, every new MBA that graduates from Harvard, Stanford, MIT, they say software testing, stable, predictable, repeatable process, well-defined. That should be automated. We should have a tool for that. We should get the humans out of the way. What the heck? Does that really work? To what extent does that work? What does that look like? We're going to talk about it, particularly with a focus on large language models. So my goal today is to explain to you how large language models work at a conceptual level that is deeper than anyone else you've ever met. And I got to say, that's just some guy who's kind of a programmer and consultant. 3 years after these ideas reached mainstream, that's kind of weird. I shouldn't be doing that. I shouldn't be capable of doing that. So we'll see if we can achieve that. I think we do that, that's a big deal. Because what that'll enable you to do is, if you understand how they work conceptually, you'll know whether they're fit for purpose for the claims people are making. I think that's a big deal. And we'll talk about what's possible and some ideas for you. So to start it, we have an audio to play. This is from David Gardner, co-founder of The Motley Fool. I don't know, but they probably influence tens to hundreds of billions of dollars of financial transactions a day. And he came on a podcast to talk about the rise of digital agents. I don't know if we're going to be able to get the audio to work. Hold the mic to it. Down there.
The big thing is going to be digital.
So, nope.
Who's creating them? Who's using them? Who knows them? I mean, I now know some people in my life who basically are saying, I have 20 full-time software developers working for me. They're all agents. So my output has grown dramatically. And that's why you're seeing the salaries and the role opportunities for non-AI techies collapsing. And you're seeing the AI salaries higher level.
You're not back at all.
Companies are realizing this person knows how to do this.
Well, the good news is we literally, because of the fact that in this world that we live in, and you'll notice I am an accessibility for all advocate. When you can't necessarily hear something, we give you an alternative, and I certainly can. Yes, the big growth rate is going to be in digital agents. So, and the only way to understand that is to be talking to somebody who's creating them, who's using them, who knows them. I mean, I know some people in my life who basically are saying, I have 20 full-time software developers working for me. They're all digital agents. So my output has grown dramatically. And that's why you're seeing the salaries and the role opportunities for non-AI techies collapsing. And you're seeing the AI salaries spiraling, right? Because companies are realizing if this person knows how to do this, they know how to bring their 10 agents with them. And they are producing at 10x. So why wouldn't I pay them 50% more, right?
So that's the quote. So we're going to do a little deconstruction on that. So if you were in our workshop on Monday, you know that they're not actually producing 10x because of all the other factors in the delivery cycle. But ignoring that, does anybody know what they're talking about? Like, really? Do you really know what he's talking about? Is that Llewellyn with his hand up? Liar. So, is anybody doing what they're talking about? Oh man, okay. So I think there are two major logical problems with this as written. So if you studied rational thought in college, can anybody name the two logical fallacies that are visible in this text? I would submit to you, and you could disagree. We take it to the hallway, no problem. There's two fallacies here. The first is what's called equivocation, which means they're using vague and ambiguous terms that are up to the reader to interpret. They can be interpreted in multiple ways. So the vast majority of the population will interpret things in one way, which is not true. But there is another arguably reasonable interpretation that is true. So you sell the one, and then when you're challenged on it, you fall back to the other. So I will say, for some definition, I can absolutely believe that Llewellyn is doing something like digital agents. It just might not be what we all think of when we hear those terms. Second thing he does is he confuses present and future tense. So you'll notice at the beginning, the growth rate is gonna be in digital agents. And then he jumps immediately into present tense. So the last person who did this in a public forum that I know of, gosh, what was her name? She was a CEO of a company called Theranos. Oh. Elizabeth Holmes. And she did an investor pitch where this literally happened. She presented as if they were using, supplying the military and Department of Defense battlefield operations with their technology. She used present tense once and then future for the whole rest of the presentation. And she is in prison for investor fraud. And that was one of the counts. I don't think David Gardner had he's not trying to mislead the general public. There's nothing bad. He's not a criminal. Don't get me wrong. But we're being really sloppy in our language and the way we communicate. So I like to get a little more specific at the conceptual level for how ChatGPT does what it does. So we're going to start with tokenized input, which means you take a sentence and you break up every different word into a token, right? But words have meaning and context based on each other. So if I say, Joe eats, shoots, and leaves, it might be a panda bear, or it might be a cowboy. Very different meaning. So you can assign weight to different words and you can build a linear algebra matrix, which now you have a vector function. And you can throw that into a huge corpus of data and you can come up with a response. And that's the most math I'm going to do, don't worry. But most of us are familiar with linear regression. So you can plug numbers into Excel and a bunch of XY data points, and you can do a print to fit line. And machine learning does the basic machine learning. It's pretty simple. It is as if you can think of LLMs as doing the same thing with words. You can think of how you would train that. Most of us are familiar with both Apple and Google. They have log data. So when you start to type in a sentence, it'll auto-complete it for you. Pretty simple. Well, you could do that with a much larger corpus. You could do that with a text declaration of independence. You could take a word out and then run 1,000,000 times and see what simulation finds the right word to fill in. You take that one, and then you take 2 words out, 3 words out, 4 words out. Eventually, you're recreating the Declaration of Independence. How are you doing it? Well, you have an input vector that gives you that output. ChatGPT was reinforced by humans who looked at output and said, this is good, this is good, this one's bad, this one's bad. Same way you do an eye exam. That's a neural network approach. Same way that your Gmail can market as spam, it can recognize patterns really good with fuzzy logic based on text. I mentioned context before. We're going to add natural language processing, which we've had since Ask Jeeves, so you can ask a question and get an answer, and conversational skills, so you can say, that's wrong, do it again. And it feels like you're talking to a person. Oh, sorry. I guess I was wrong. So I had that conversation with ChatGPT last week. I convinced it that 2 + 2 is 5. It took a lot of work, though. I will say it took a lot of work. I got it to parrot back to me, which is what it's doing. There's a couple other things. So there's a randomization element so that it feels like you're talking to a human, which makes it not reproducible. If you get the API, you can turn that off. You can turn that down to 0. But if you put all those pieces together in that way and actually do it instead of just talking about it for 3 minutes up here, you can build a large language model. And of course, for data, you want to give it the whole internet, which gives it all the biases is the whole internet. Now what the companies are doing is they're training out the biases. which is good. So I want to check myself. Has anybody else said, oh yeah, someone did a better explanation of LLMs to me. Matt, this is not so good. Why are we the ones doing that? That's right. You want to talk about the hype cycle?
All right, so we have had a number of times that we have discussed over the course of this weekend, the Gartner hype cycle. So if this is the first time you've actually seen the graph, here it is. And the whole point behind the Gartner hype cycle is you start off with something that comes into the market. And we've had this in many ways. The Gartner hype cycle, if you want to get right down to it, to borrow, I believe I was talking to Wayne and Boss this morning, the Gartner hype cycle has existed as long as James Watt's steam engine has been around. And you can trace the exact same experience. What is it is you start off with a trigger. Something is generated, something is put into the market, and people get excited about it. And usually it's a huge jump up, right? And you reach what is called a peak of inflated expectations. Now, again, I'm not making any value judgment here. This is just how things happen with every technology you can think of. We reach a peak of inflated expectations because all that we've been sold or told is promises. Just like I'm sure the steam engine is going to change the world in the way that you are able to generate power. Does it? Yes. Is it a very involved and thoroughly difficult process? Absolutely. And so anybody who was hoping that a steam engine was just going to replace people immediately were disillusioned when they realize, oh, there's a lot of work and effort and science and technology and detailed hard stuff that goes into this. And so negative press starts. And then you might have, for example, an initial product offering that promises the moon but doesn't actually deliver and disappears. And we've already seen that. There are a number of AI initiatives that have gone belly up or have disappeared or have been acquired by other companies. And also other companies who have done things said, well, that doesn't quite work the way we intended, but they kept trying and tried something different. And they found something that works for that area and continued forward. And so during the trough of disillusionment, as we will say, in other words, reality sets in, we understand that, okay, this is going to be harder than we thought it was going to be. And there's going to be a lot more to this, but that's also a good thing because it resets our expectations. It gives us a chance to say, okay, yes, this is not going to revolutionize the universe. It's not the complete reintroduction of something. Let's just go back 10, 15 years. The cloud was supposed to be this great revolutionary advance, and it was going to change the entire world and the way that we thought of computing and power. And in some ways it has. But let's face it, at the end of the day, you're still buying time on somebody else's computer. So we've sort of gone back to the old mainframe. Does anybody disagree with that? From a metaphor perspective, we have. But what's happened is that we now have a much more realistic and honest view of what cloud computing is. And now it's, hey, how can we legitimately use this? And many companies have figured out exactly how to do that, and they're raking in big bucks doing it, period. So once you get out of the trough of disillusionment, then that's where the slope of enlightenment comes in. And as I just said, the whole point to the slope of enlightenment is, okay, we've gotten over the pie in the sky claims, and we've also now gotten over the doom and gloom, oh, it doesn't really do anything, to, all right, what's the middle ground here? Answer is, yeah, it actually does quite a bit well. And spoiler alert, AI does quite a lot of things well. And as we reach up, then we get to the plateau of productivity. And that's a much more stable place. Cloud computing is there right now. Arguably, automation is there right now. And because of that, it's something that we understand. We have well established. It's part of the fabric of our world now, and we can appreciate that. AI is now going to that point, and I do not believe it's going to be very long before we reach that plateau of productivity where more people genuinely understand what it is, what it does, how it does it, and how to genuinely reap the benefits of doing so. And I know that there are several people out here who are already marketing products that do that.
So, couple things. I remember XML magazine. It was a paper magazine. There was more than one of them. There was like competing XML magazines. There was XML conferences. And then IBM came up with a product called WebSphere, and you had to write 150 lines of XML to get the thing to boot. And we like, this is not going to be that. And today it's got a place in IT, and we use it sometimes, and we understand it. It adds some value. Cloud compute, blockchain was another one. Remember, like people were calling me up saying, "God, you got to get me a blockchain job." I was like, "I don't think I do." So the idea that we could start to understand how to integrate these technologies um, and see where they add value. That's what we're going to go to next. Let's talk about what LLMs do. So they summarize and regurgitate existing information rather than generating truly novel insights. So they're mostly based on text. They mostly represent text. They mostly guess what the next word should look like instead of having an internal model of how the world is and telling you how the world is and will be. So they synthesize data from multiple sources, but lack the deep insight we often expect from AI. So I'm not sure this is a great example, but you could feed LLMs the transcripts to all of the Transformer movies. Or a better example might be every episode of Friends. People have done it. And then say, give me an episode of Friends. Or you'd get the Transmorphers movie. You know, Joey would say, how you doing? You would get the cliches of the most commonly repeated things. But there's a place for that. But is that our talk is about that in testing, right? So if you have well-documented test descriptions, plans, objectives, feature descriptions, defect histories, then you feed it into the software and say, this is going to change. You've got a hope of that coming out, of something coming out that's valuable. But if you've got all that, it's not going to be that valuable because you got all that, right? And if you don't, it's going to be garbage out, garbage in, garbage out. So when you start to see claims that are made about tooling, if it is based on large language models, we can start to set a test design, right? Right. So who here tests software in some way at some point in their job? Doesn't have to be all day. Think about the most important bug that slipped through, the one nobody thought of, right? The one that was like, oops, gee, we just slagged the database, it locked up, and no one can log in. Or even your second worst ones, the ones that impact a major percentage of your customers a lot of the time. Wasn't the problem that nobody thought of it? So nobody wrote it down? It's not in the requirements. You've never had a defect like that. It's not in your old plans, not in your designs. If it was, you didn't test it, right? So almost by definition, if we are using LLMs for test design, there are some exceptions we can get into later. It's not going to come up with interesting test ideas that really save our bacon, that become that story. And you know the story. We don't need this role. We don't need this function. Why are we doing this? Sit down and let me tell you a story about what happened 3 weeks ago. Right? And we're more successful in the field as testers when we get the executives to tell those stories for us. We don't want to tell that story. We want them to. We found it before it went out. It's not going to find those things. The other way we could do it, which Ben Simo is doing that right now for a company in I forgot their name, their company in Europe. And you could feed it heuristics about your platform and heuristics about the failure modes and what commonly goes wrong on a mobile device. And you could say, give me some test ideas for a mobile device, and it'll spew out a whole bunch. But then you got needle in a haystack problem because it's going to have too much. So you've got to train it to know the thing that you didn't think of to come up with yourself. Seems unlikely we're going to be that successful at that. There are people trying. Yeah, boss. That's easy. So we're going to talk about that later. We have a couple slides on that. Michael says yes. Speaking of which,
so I have a very simple place that I want to look at this. When we're talking about, we're putting out our pronouncement here, and I want to take a pause here, and I want to say, are we being fair in what we're saying? Okay. So we just said ChatGPT and large language models. Now, please notice, we have said AI in testing, and yet we've spent all this time talking about large language models and ChatGPT. Notice we have not said word one about the various fill-in-the-blank.ai testing tools. There's a reason for that, because the strong domain knowledge that exists there is going to be built into those tools. And we already expect that somebody who has expertise in software testing and skill in that has already gone through and done a lot of the efforts necessary so that that AI enhancement can be placed on top of what it does. We're taking a step away from this, and we're going somewhat platform agnostic by using ChatGPT, because that's the popular platform that a lot of people have access to, and it claims to be able to do a lot of things for a lot of people. So that's why we're focusing on that. And I want to be clear with that. Yeah.
if you say, I have a tool and it guesses DOM locations so that when you move your button, but everything still works, it can find the button and click it. That is a form of AI. I think that is a well-documented, worked well technique, and you might get 3, 4, 5, 6% productivity improvement off of it.
Which in this world is actually very big. When we say that, don't mistake 3, 4, or 5% as, oh, is that all? It's actually quite a bit. But for this, are we being fair? So let's look at summarization and synthesis. And that is the point that is what we do. If we feed in information, if I give a limited amount of information to an LLM, it will look at all the possible text that I've given it, and it will say, you could go in these directions, and it can fill out considerably more. If I say, write me an article that has 1,000 words to it, it'll write me an article with 1,000 words. If I say, write me an article with 2,000, it will stretch and it will give me that too. Sometimes it will give me very good results. Sometimes I'm going to have to go through and go, oh boy, there's a lot of padding in here. Why? Because I asked it to give me 2,000 words. And so it's going to give me 2,000 words, whether it's relevant or not. So that's part of the challenge that we face, is that it's looking at learned patterns and it's looking at things that have been written before, but it's unlikely to produce anything new or learn something that it doesn't already know about, okay? It's also, LLMs rely on clean and somewhat organized data so that you can produce a useful output. In other words, if you have a company that already has well-established test processes, you have a company that has a clean database that has good structured data, guess what? Your company is going to be in an excellent position to benefit from AI and LLMs in particular. If your company is in a sort of chaos, has a loose collaboration of whatever data happens to be around, and we don't really know what the heck to do with it, and you throw AI at it, you're not likely to have AI suddenly gather that all up and put it into a nice little structure, give you a tidy bow and go, oh, here's what you should do. That's what people are hoping AI is going to do for them. We're not there yet. And the companies, and the irony is to this is the companies that will reap the biggest benefits from AI have already done the work necessary, or a fair amount of it, to reap the biggest benefits. And I don't think that I am on any controversial ground saying that.
Yeah, thanks, Michael. So I think you just said that point, and yeah, we still need it. We still need overall test strategy. I think I'm going to just keep going. So what we'd like to do now is to point counterpoint on some specific practical applications, which I think speaks to Llewellyn's question. So, yeah, log file analysis. Couldn't we just use Splunk?
And here's where the Abbott-Casella routine begins. All right, so we have chosen to play good cop, bad cop for this presentation. So All the things that are going to be that I personally or that we think are hip about it are coming from me. Yay! And what is hip about machine learning for log files analysis? And the whole point is we can analyze those log files. We can find common use patterns. We can find where our performance bottlenecks are. And we can look where our test coverage needs to be by looking at the maps of where users actually go. That's a good thing. That is valuable if you have large, complex systems. And if you have to do that manually, oh, good heavens, that's going to take forever. AI can do that. You can take a tool and throw it at, in fact, I believe there is a tool out there that can literally go out and test hundreds, thousands, millions of websites and actually get you results from it. I physically saw it happen. I witnessed it in a tutorial a couple of years ago, and that was pretty darn cool. But the point, again, I'm going to say is that's because somebody did the work, somebody did the legwork to make that happen and developed a tool specific for that purpose to leverage that ability. Again, I don't think that's controversial. If you take the time, you do the effort, you do the analysis, do the hard legwork to make all that happen, AI is going to definitely be a benefit to you.
So let's be precise in our language. So the tool existed years ago because it's a spider, and it'll give you 500, 404 errors, that kind of thing, broken links, and it's not AI, right? So we could do Flunk, we could do grep, we could do log file analysis with scripting. We've been doing this for years. We know how to do this. It's not really a case for LLMs. Although there might be a little bit of kind of sprinkle on top, right? Where I do think the conversational model and the feedback, the ability to tell them to refine the model in text is a little better with LLMs. I will admit it's a modest improvement.
Yes.
Within the context of this web server, right? And it could say, all right, I'm gonna see which lines to put in for it. It throws it back, right? Now, that's not a high precision measurement or instrument, but it's a collection of stuff. Oh, we gotta.
I just realized we're on Zoom. Nobody has heard what you just said. Quickly, Per.
Okay, so the thing that I'm saying is that an LLM is able to make fuzzy inferences from one thing in text or statement to another. And things like Splunk require you to know what you're looking for. I know I'm looking for error. I'm looking for exception or whatever the phrase is in my logs. And that's great and it's awesome. And you can do precision stuff with those kinds of tools. The LLM lets you say, I'm not sure, but show me stuff that looks like it might be someone having a problem, or it might be the server having issues and things. And it uses its notion of language and semantics and embeddings and all that crap to say, given that, and the text in here, this statement looks like maybe a problem, this one looks like maybe a problem, and it pulls it back. Now, it's not all sorted, it's not all grouped, but that's information for me to go, oh, wow, and now I can refine my Splunk query, or now I can do that. But it's that fuzzy matching that's one potential power of some of these things that you didn't have before. And I think that's a sprinkle over. It's a legitimate sprinkle over on the hip side. And you can't do that with the other tools.
Good point. Absolutely. I don't disagree. I think if you look at what we presented on how they work, how LLMs work conceptually, that could work. I don't know a lot of people doing it yet. It may just because we're early in adoption. I think a lot of it is getting the data in, because you don't want to upload that data to OpenAI. You want to have your own server, but you could have your own private Lambda server, which is open source, and you could do that for sure.
We do have to keep moving on. Thank you very much for that, Wayne, but we've got a whole bunch of things to still cover here. So defect analysis and prediction. So what's HIP on this? Basically, we could use AI models to predict defective code. We can analyze our defect data, our change histories, code metrics, and all of that. That can help us focus our test efforts on what the high-risk areas are, and it can improve test prioritization. In other words, we can use AI to help us find the heat. If anybody's familiar, I'm sure people are familiar with that, when you've caused something to happen or you've done something through change management and you've had to go back and you've had to fix a bunch of outlying areas that you didn't realize were actually connected to the area you just fixed. In my parlance, I've always said, whenever you make a fix, go look for the heat. And that means go look for everything that that thing touches. And if you don't know where that thing touches, then this kind of defect analysis and using AI to look for it can help drive that all together. You may only do this one time and it may be very deeply hidden in a totally different repository, but because of this, we've analyzed this module and this module are connected to each other. And as long as it exists there and there is a mapping to it, it will find it. But of course, you have to know to push and look there.
Yeah, and there are there's a couple things there. You can, in terms of analyzing the code, there are tools that instrument the code to see what lines of code are executed when you run your test, see what's connected to what subsystem. So if we make a change here, we need to change all these other things over there. And people are using AI tools to do that. I don't think they're large language models. Some people have had some amount of success. In terms of defect analysis and prediction based on however we track our defects, you can probably do that. It's probably not structured in a way that that a human being looking at an Excel spreadsheet, finding risk categories, tracking them, summing them, and sorting, can turn their head sideways and squint and see what's coming, what to test for. What is not in our test strategy we should be testing for. I really haven't seen that happen yet. I don't know that an LLM is going to be successful because of the way the data is encoded. But that's data.
We're going to fight over this one. So test data generation. I think this is probably one of the areas where a large language model can absolutely be helpful, especially if you need to generate huge amounts of data or very large tables. But again, it comes down to if you just tell an LLM, hey, generate me 10,000 usernames or generate me 10,000 address listings, and you don't give it a lot of specifics, it'll spit it out to you. It'll absolutely give you what you have. Now you might decide, oh, you know what? I need something a little bit more granular than that. And then you can go and tell it what you want it to do and ask it to do that. And it will give you newer results and it will refine it. And ultimately you will come up with what you were asking for. And if, of course, you already off the top of your head know what you want your test data to be, and you're just saying, hey, I want to generate 100,000 names, and I'm just picking an arbitrarily large number. It could be whatever. But I already know that I want the first name, I want the middle name, I want the last name, I want addresses from 15 different countries. I want social security numbers, I want government IDs, I want passport numbers, and span out as far as you want to go, as much data as you want. Now, can you deliver this to me in this format? And it will go process, think, do its thing. Yeah, absolutely. Here you go. Here's your CSV, or here's a table that you can use to feed into a database and do whatever you want to with it. So yeah, can it do it? It most certainly can. Can it do it fairly quickly? Yeah, that's been my own experience. I've actually been able to generate that information pretty effectively. Again, with a caveat, I already knew what I was looking for. I already knew what I wanted to have in that place. I had a pretty good idea. I just didn't want to have to go through the legwork to make it or have to go write some code to do it. Is it the best way to do it? Questionable. Does it work? Yeah.
He just said 100,000. He said that he did it, right? So correct me if I'm wrong, Michael. Last night, I came up with a trivial scenario to generate 100 names and apply a very simple transformation to it. And it said, I don't have enough compute, and we did it with a paid subscription. I don't have enough compute resources to do this. Sorry. But here is the code for you to write your own fake name generator script for you to do it. Did that happen? So
Yes, that is exactly what happened. Again, please notice the caveat that I said prior. Why was I successful and why was Matt able to cause?
yeah, why were you? I'm really curious. How did you get the 100,000 names? Why didn't it do that? Okay, 10,000.
It's still a pretty decent number. But again, the point was I started with a prompt that was very specific. Please generate me 10,000 names in the following format. And I very succinctly told it what I wanted it to do one time. It was able to do that because I gave it all the information up front.
Right.
And I was able to show it exactly what I wanted. And it did also come back to me and say, hey, you know what? You want addresses from Brazil. I'm sorry, that's not in my library. But I have addresses from these other countries that you can use. And I looked at that and went, okay, you know what? That's not a deal breaker for me. Fine. And I moved on with it. So again, I will label that as a success. Was it a 100% success? No, it wasn't. But you have something that you got to experience, and there's a reason why yours was interesting. Go ahead.
Well, it was a transformation. So I said, thanks for your first order report. It's not good enough, so please make these changes. And then it had to apply those changes across all the rows. That took too much compute. And it wasn't a significant change. It's like breakout address by city, state, and zip. Or there was, give me middle names, but only give me middle names for 85% of them. Something like that. And that was too much.
Create bell curve distribution for the
created bell curve distribution. I thought that was in the first request.
It was the first one, and we only had a small number. That was part of the first order. When you started messing with the order of what you wanted, and then generate me the file, and then do this other thing that I want to do, and then generate me the file, and then do this other thing that I want to do, and then generate me the file. So you're cascading through a number of transformations that it now has to keep track of everything that it did before.
So I think between the two of us, we actually came up with a realistic expectation for the tool. That's crazy. I will say that this is the technology as it exists today. It is getting better. We think it is going to get better in what we call punctuated equilibrium, which means it's going to be pretty much the same and then something big, pretty much the same and then something big. So I don't think it's going to be this continuous improvement to this amazing land. This presentation is scoped to the technologies as they exist today. Let's use it to write code.
Okay, so I have definitely done this. I have used this for very specific purposes. In fact, I had a distinct reason to do this over an extended period of time, and I wanted to practice this. So one of the things I wanted to do was I wanted to develop a curriculum, and I wanted to develop a consistent curriculum so that I wasn't constantly reinventing the wheel and making new stuff up. And part of doing that is, if you've ever had to create a programming course or anything, is you want to have your examples be consistent. You want to have them build off of each other. You want to have them grow and use concepts, but you want to use a similar data so that you're able to keep working with the same concept and project. One of the most infuriating things is when somebody wants to teach you something and they go into totally different domains and you can't keep them together. When you have a unified project that keeps the same sentiments, you're able to concentrate and focus on it. And so that's one of the things I think this would be a fun little project to throw at an LLM. And specifically in this case, it happened to be C#, which has been around a long time. And I said, let's go ahead and let's try out this idea. I want to make this process of developing code, and I want to develop the code through all the steps from beginner to fairly advanced, object-oriented, polymorphism, etc., and keep it so that we can talk about this ever-growing geometric library. That's just what I happened to pick to do it. Did it do it? Yes. Did it do it in the most elegant code imaginable? Honestly, no. Was it usable and suitable? Most of the time, yes, but I want to make an emphasis on the most of the time. There were absolutely periods where it got confused. It was not sure what it was looking at for the instructions I had to do. And again, I had to go back and prompt and reprompt and refine prompts, sometimes start over, but it did generate code for me that was useful. Selenium code, being able to connect to a website, to be able to create a page object model, to be able to connect and run an assert based off of whatever's there, it could generate that base level code. I will admit, linearly. So for those out there who want to have their code nice and clean, you will have plenty to refactor. But it did it. And it did it in a pretty quick manner. When I threw Playwright at it, Playwright has some new stuff to it, and it just genuinely didn't know about some libraries of Playwright. And I had to either remind it or help it or actually upload code to it for it to go, oh, based off of that, cool, do this. So, HIP, can LLMs write code for you? It absolutely can. Is LLM going to write cutting edge code for you? Arguably not, but is it going to be able to write code? And I see Llewellyn's got his hand up there right now.
You made a statement earlier that LLMs can't do creative original work, and then you just sort of went past it. And you're kind of coming back to it here. I want to, if you look at like Google DeepMind, it's discovered like 50 new materials that it's synthesized in a lab that didn't exist on Earth before. How do you reconcile that with it can't create new things?
I just looked at the text on the screen and said, unlikely to generate deep insight.
Fair enough.
So if you work at Google and you throw 10,000 programmers at it, you'll probably find something.
Yeah. Okay, so it's just a likely, it's just a probability curve then.
In this case, yes. And again,
Yes, sir.
the point that I was saying from this point, and
we're talking specifically about creating novel and unique creative ideas to test software that no one has ever thought of before.
But there's an element of creativity that is just, I combine two things that already exist into something that hasn't existed. Like a Reese's peanut butter cup.
Yeah, and that moves you down to unlikely. Yeah, sure.
Okay, but it feels like that's still in the neighborhood of what an LLM can do. It can take two things that do exist and combine them. Like it actually feels like it's kind of good at that.
I would challenge you to go find me some test ideas that it generates for your website that save you from that amazing thing that nobody thought of or wrote down. And then we'll talk. Because you don't have any.
Nobody thought of. That's a big problem. But we're also plagued by, thank you. So for the mic, we are plagued by nobody thought of. That's a big problem. It happens a lot. But we're also plagued by a lot of, oh, dang, this is the thing we always really should do and forgot it was relevant this time. I go back to early 21st century where the whole world would be taken down for like a week by viruses that went around the world. Those were all buffer overrun bugs, all of them. It's a classic pattern of bug and testing. What's that? CrowdStrike.
Mhm.
Yeah. Well, but okay, fine. But I'm old enough, Still. Yeah, and actually one of them was an index server from Microsoft that was introduced as a hot fix, right? Because my test manager at the time had been on the team and had been under his thing. So I think that the point that looking for the salience of old patterns to this situation is highly utilitarian.
We have a slide for that.
Yeah. And the question
We're going to get to it.
And the question though, it's not whether that's utilitarian or not. I think you brought up the earlier point, which is the culling. It's like it's a fire hose of combinations and picking which ones. I think that's the harder problem because my experience has been if you give an LLM the right input situations, it matches thing to thing with a decent amount of salience.
And we have a slide for that.
Okay, good. I'm glad. But the hard
So-
part is getting down to which of these.
But if we come up with examples like we should magically have found a way to warn us about CrowdStrike or this LLM index server. Now you want an AI to say, no, you can't go to production. I'm not going to let you because I know better because of this thing that happened a long time ago, which might happen again. And if that's what you want, that's a different talk. Can we move forward? We got to go.
Yep.
Test cases, test ideas.
Can I stop for just a second, this is supposed to run till about 5 more minutes, but we can extend it a little bit and we can slide the schedule, about 15 minutes for everybody for this morning.
The public schedule says we're going to be done by 9:15. We're going to
Yeah.
be done by 9:15 and we will hang out and talk to anybody that says, but wait, what about?
And then we can start
Absolutely.
the next session at 9:30 after that.
All right, Joey?
Yep.
Okay. So this is one that we come up with. And again, anybody who, test cases, thank you. So anybody who knows Matt and I are going to already know, and I will preface this, that Matt and I are not fans of classic test cases. However, I will caveat this in the sense that many organizations require them. They have to be there. They're mandated. And so for us to just say, you don't need to use test cases, some people are going to be excited by that and some people are going to run us out on a rail. We respect and understand that. So can LLMs help you with test cases? Yeah, absolutely they can. Because they can give you basic case structures. You can go through and refine and expand your cases. It can look at what your code base is. It can look at what your interface is. It can look at what your locators are. It can determine the logic of your JavaScript. And it can make very basic assumptions looking through that to say, oh, this page allows you these paths. It allows you to go these locations. It allows you to select these items. If you have an example that I will throw out is I am a big fan of accessibility testing. Accessibility is a huge area to where you can load up an entire WCAG database of recommendations and possibilities, throw it at your code, and it can literally walk through the entire WCAG thing and it can say, hey, this doesn't match this. This doesn't have this value. This doesn't have this. And you can create a very specific example of where do you want to look for these things. So you can generate test cases based off of what your code says, based off of what your pages and objects say, and you can make some pretty complex systems and you can get a lot of output from it. No question.
I would say if you want to generate a test idea list from a blank sheet of paper by describing a screen, it's fine. It'll help you come up with your test ideas really fast. Doesn't take me a lot of time. Like I don't think that's the hard part. Like that's the fun part. That's easy. But that's fine. It might help you create documentation you don't want to use or don't need. That creates weight that slows down your project that you throw out or throw away later. I'd be worried about that. I'm going to go through because like they said, we want to, I thought this was fair that AI tools they can automate definable repetitive tasks, manage large data sets and identifying repetitions and patterns. I think Wayne makes a good point that LLMs sprinkle a little bit of fuzzy pattern recognition on top. But this is the one I kept saying we're going to get back to it. This is what you need, right? So if you have good historical defects, you know your platform weaknesses, you know your test objectives, you have a good coverage model, you know your emergent risks, you have core user scenarios and stories and requirements, right? You can go through those and see, you can use Karen Johnson's RC heuristic, what's recent, what's core, what's risky, what's configuration sensitive, what's repaired, what's chronic. You can distill that down into test models, activities, and output. If you have all those things, you throw that in an LLM, you might get some pretty, Llewellyn's first question was, hey, can I just get rid of the repetitive stuff? You might get some acceleration in your planning. The thing is, if you've got all that, we got to do the work. We got to put that together. Most organizations don't have that. If they have it, it's a bunch of JIRA tickets that are all filed in very inconsistent, wildly different ways that mean different things. So your LLM would say, you've got a lot of typos. Gee, you've got to go fix them typos. That's not the that's not what blocks our users from delivering the software. So we've got to have it in the right structure. And if we do, I think Wayne's point holds, we can accelerate our work significantly. Now, I should say, like, test riggers here, what they do is very different for their text to coding. And it's not an LLM from our perspective, except in the code generation part. We can talk about that later. But in terms of using LLMs to accelerate your work, I think you need to have your data picture right.
So here are some of the takeaways we want to be able to have here. And we have a bunch of slides here. And again, we extended because we directly took questions from the audience. But what are our takeaways here? First off, your artifacts. Do you actually need them to begin with? So if you are using artifacts to generate test cases or data because they're necessary, and to store, visualize, or get the same results, you can do it from a different format. But if you're focusing on your outcomes, you want to keep the docs that are light, fast, and valuable. And LLMs can certainly help you do that if you want to generate that data. The question that we again ask is, because we tend to be less test case heavy, is the lighter the documentation, the quicker that you're able to communicate, the better overall your testing is going to be. If you work in an organization that is documentation intensive, LLMs can be really fantastic. We want to prioritize accurate test data. And again, it comes back to what we said previously. If your test data is in good shape, AI is going to help you a lot. LLMs will help you a lot. If your test data is chaotic, you're going to have to do a lot of additional work with the LLM to get it to the place you want it to be. Can it be an assist? No question. Is it going to do the work for you? Arguably, no. And again, go ahead.
The bottleneck in delivery is usually the speed of human communication. It's usually the people. It's usually the multitasking. It's usually the waits and the delays and the approvals. It's usually the waiting for someone to do the work. So if we have improvement outside of the bottleneck, it's an illusion. Llewellyn? So if you fundamentally change the nature of the work to collapse the roles, so the analyst is also doing the programming, and that programmer is using an LLM to do things, you can improve your velocity. But that's not given to you by the LLM. That's given to you by making a super programmer who can also do analysis, which was the core insight of extreme programming 25 years ago. I mean, thank you for the recommendation. Yes, I do consult. Llewellyn's pretty great too. Yeah, I think this speaks to Wayne's thing. LLM-derived code generation works well for common problems that are already solved. Give it the right inputs, can usually give you pretty good outputs. I mean, you're speaking on something slightly off, but it can be challenged to implement novel and unproven areas. And
I think we are out of time for the
60
questions,
seconds.
but we will be happy to talk to anybody in the hallway or during the rest of the course of the day.
And so I would just say this was our best. I promised at the beginning was to explain how LLMs work better than anyone else has conceptually. I think we kept it. Everything else was gravy. I hope you liked it. Thanks.